Machines by Lillian Duggan. How do machines help people work? Measuring work. When you think about work, you might think of washing the dishes or doing your homework. But scientists think of work differently. Work means using force to move an object a certain distance. The force comes from pushing or pulling. If an object does not move when you push it, you haven't done any work. Use this equation to find how much work is done. Work equals force times distance. Work is measured in a unit called the joule. Joule is abbreviated as J. 1 joule equals 1 Newton times 1 meter. Let's say you push a box using a force of 200 newtons. The box moves 1 meter. You can find the work done by multiplying the force by the distance. 200 newtons times 1 meter equals 200 joules. Work and machines. In science, a machine is any device that helps people do work. A machine does not have to be large and complicated. Many machines are very simple and have few parts. A simple machine is a tool made up of 1 or 2 parts. Have you ever used chopsticks to pick up food? You hold them in the middle and squeeze the ends together. Then you move the food to your mouth. A pair of chopsticks is a simple machine. They help you do work by using force to move food to your mouth. Bigger machines that have many parts are called compound machines. A compound machine is made up of 1 or more simple machines. Cars, trucks, and airplanes are compound machines that have many parts. A wheelbarrow is a compound machine made up of several simple machines. How machines help. Machines do not change the amount of work that is done. Remember, work is equal to force multiplied by distance. Machines make work easier by changing the distance over which the force is applied. Spreading the force required over a longer distance decreases the amount of force you need to apply at one time. A car jack is a machine that helps you lift a car. Cars are too heavy for people to lift. A jack decreases the force that's needed to lift such a heavy object by applying force over a longer distance. A screw-top lid works the same way. Without the screw-top, you would have to slam down the lid hard to cover a jar. With a screw-top, you must move the lid a longer distance, but you use less force to close the jar. Machines and friction. When you use a machine to do a job, you put work into it. You supply a force as a push or pull. Sometimes the work can come from another energy source, such as a battery. The amount of work a machine does is always less than the amount of work put into it. Some of the work is lost to friction. Friction between the moving parts of a machine gives off heat. The more moving parts a machine has, the more work is lost to friction. Lubricants such as oil, wax, and grease can help reduce friction, as can wheels, rollers, and balls. The wheels on inline skates have ball bearings inside that reduce friction. What are types of simple machines? Types of simple machines. There are 6 types of simple machines: the lever, inclined plane, wedge, screw, wheel and axle, and pulley. Lever. A lever is a simple machine made of 1 or more bars resting on a support. The support is called the fulcrum. One example of a lever is a crowbar. In the crowbar on this page, the fulcrum is at the bottom. The cinder block that the crowbar is lifting is the load. The load applies a force on the crowbar. To lift the load, you must apply a force to the opposite end of the crowbar. This force is called the effort force. Using a crowbar, you could lift a heavy cinder block with much less effort than you would need to lift it without one. But you have to apply the force over a greater distance. If the fulcrum is closer to the load, less force is needed to move the load, but the load will not be lifted as high. If the fulcrum is closer to the effort force, more force is needed to move the load, but the load will be lifted higher. There is always a trade-off between force and distance. Types of levers. The location of the fulcrum, load, and effort force is different in different types of levers. First-class lever. In a pair of pliers, the fulcrum is between the effort force and the load. You apply the effort force when you squeeze the handles. Second-class lever. In a nutcracker, the effort force is at one end, the fulcrum is at the other end, and the load is in the middle. You apply the effort force when you squeeze the handles. Third-class lever. In a crab's claw, the fulcrum is at one end, the load is at the other end, and the effort force is in the middle. The fulcrum is a joint that connects the claw with the crab's arm. The crab applies the effort force using muscles in the middle of its claw. Inclined plane. Another type of simple machine is the inclined plane. An inclined plane is a slanted surface. A ramp is an inclined plane that people often use to make lifting easier. Suppose you have to move a heavy box up a flight of stairs. As the diagram shows, moving the box up a ramp requires less force than moving it up the stairs. However, the load must travel a greater distance up the ramp. The amount of work is the same in both cases. The wedge. A wedge is a simple machine made of one or two inclined planes. In a wedge, the edges of the inclined planes come to a point. A wedge cannot do work unless it is moving. A force applied to the flat end of the wedge moves it forward. The inclined planes change the direction of that force. Wedges are useful for cutting objects or digging into the ground. The screw. A screw is an inclined plane wrapped in a spiral. The ridges on a screw are called threads. If unwound, the threads of a screw would form an inclined plane. Screws are often used to fasten things together. Like other inclined planes, a screw decreases the force needed to do work, but it increases the distance. The pointed front of a ship, called the prow, is a wedge. It helps the ship move through the water more easily. Wheel and axle. If you've ever ridden on a Ferris wheel, then you've seen a wheel and axle at work. A wheel and axle is a simple machine made of a wheel with a rod running through the middle. The diameter of the rod is much smaller than the diameter of the wheel. When the wheel turns, it moves a much greater distance than the axle. However, the axle's smaller turns are much more powerful. A wheel and axle makes work easier in one of two ways. It either increases the distance through which a force acts, or increases the force itself. The axle of a Ferris wheel turns only a small distance, but it makes the wheel turn a much greater distance. A water faucet in the shape of a wheel is another type of wheel and axle. When you turn the wheel, or faucet, the force you use is increased in the axle. The axle opens the water valve. Think about trying to turn a faucet that is made up of an axle without a wheel. Pulley. A pulley is a wheel with a groove along its edge. A rope or chain runs through the groove. A load is attached to one end of the rope. The load is lifted when an effort force is applied to the other end of the rope. The two types of pulleys are fixed pulleys and movable pulleys. A fixed pulley stays in one place. When you pull the rope down on one end, the load is lifted on the other end. The fixed pulley does not change the amount of force you have to use to lift the load, but it makes lifting easier by changing the direction of the force. Escalators are machines that use pulleys. A movable pulley is a pulley that is attached to the load. When you apply a force to the load, the pulley moves along with it. The pulley decreases the effort force so that you don't have to pull as hard. However, you have to apply the force over a greater distance. This is because you must make both sides of the rope move in order to move the load. A system called a block and tackle combines several pulleys. All the pulleys in the system are attached to the same rope. The more pulleys in the system, the less effort is required to lift the load. A block and tackle with a lot of pulleys can lift a very heavy object, such as a piano. Compound machines. Most of the machines that people use every day are compound machines. You probably know that the cars, buses, and airplanes that we use for transportation are compound machines. Many compound machines have hundreds or thousands of parts. These parts form the simple machines that combine to make a compound machine. The sailboat on this page is a compound machine. It has many parts and combines many simple machines. A. Winch. The winch crank is a wheel and axle. It cranks the rope in or out to raise or lower the sail. The rope end is used to lift weights. E. Wheel. The steering wheel is a wheel and axle that changes the direction of the rudder. F. Block and tackle. This pulley system is used to move the large mainsail. C. Propeller. The propeller is a type of screw. When it spins, it pushes the boat through the water. B. Keel. The keel is a wedge that helps keep the boat stable and moving straight.